Alright, so now this is problem number 2 from the Analog and Digital Practice Worksheet. We're going to work through, and again, we're going to calculate peak amplitude, the peak to peak amplitude. We'll find the period, and once we do that, we'll be able to also find the frequency. Alright, so first task is to locate, right? So here is the highest peak. So this is the max. And this is a min. That helps us with our amplitudes. We also need to locate a complete cycle. So I'm just going to trace that as best I can. Now this one doesn't happen to start right on these division lines. It's actually a little bit to the left of it, but it also ends a little bit to the left of it. So that's going to be like if you could scoot this over, this whole graph over, it would fit between this would be my start over here, and this would be my end over here. So this would be the entire length for my period. So I've marked the graph. Now I need to know my scale. And again, that information is here. So in the x direction, it's going to be 200, and it's u seconds, not US, so that is going to be micro. Remember, micro, the official letter for micro is the Greek letter mu, but that's very hard to type. So most of the time, if you see something that's typed, you'll see it written as a u. So in the x direction, it's going to be 200 microseconds, and in the y direction, it's going to be 1 volt per division. So that's now my scale. Alright, so do some calculations. So here's my maximum, and you notice that I know it's one complete box, but it's not quite a complete box. In fact, it's half. I will say that's half a box. So that's 1.5 divisions. Each division, it's 1 volt per division. So 1.5 times 1 is going to give me 1.5 volts for peak. So I know it's 1.5 up. It also happens, oh, I notice I write this wrong. That's the benefit of doing these videos. Sometimes nobody corrects you. I guess that's not a benefit. It's also 1.5 boxes all the way to the min. So from max to min would be this 1.5 plus this 1.5. So it'd be 3 divisions times the 1 volt per division. And again, my divisions drop out, so I end up with 3 volts. So my peak to peak is 3 volts, and my peak is 1.5 volts. So now on to figuring out the period. So from start to finish is how many boxes? So it's 1, 2, 3, 4, 5 boxes, right? So if I move these over and line them up, so right, it's a little bit to the left. 1, 2, 3, 4, oops, and 5, right? And it ends a little bit to the left, right? These have to be lined up better, and they are purposely made to be just a little smaller, but it's 5. So here's my 5 divisions. Right, it tells me that it's 200 microseconds per division. When I do this multiplication, I'm going to get 5 times 200 is 1,000 microseconds. But that can be better written. Decimal point is here. I'm going to move it one group of 3. And if you remember, what's to the left, right, one group of 3 would take me from micro to milli. So the right answer, written in the best way, would be 1 millisecond. However, in order to do the frequency, I don't need milliseconds. I need how many regular seconds, plain old seconds. So I still need to move it one more group of 3. So that means I'm going to have to put in 2 zeros. So when I calculate my frequency, it's going to be 1 over 0.001, and now that is plain old regular seconds. And when I put that in the calculator, 1 divided by 0.001, I should get 1,000, and that would be in hertz. But again, the best way to write this would not to be 1,000 hertz. Wouldn't be wrong, it just wouldn't be the best way to write it, and that therefore you might not see it as a multiple choice. So I would move this one group of 3. This is regular hertz. That puts me in kilo. So the correct answer, written in the best form, would be 1 kilohertz. So the frequency is 1 kilohertz, and the period would be 1 millisecond.